My name is Haziq and this is my EM1 presentation. Now going to question 1, input the values for y equals to x squared plus bx plus c using spreadsheet formula. Now you can see in my spreadsheet formula I put a12 squared plus f4 times a12 plus h4. Now this translates to x squared, which is -5, a12, plus f4 times a12 being b times x, plus h4, which is c in this case, giving you -5, which checks out because x squared is 25, bx is 7 times -5, so 25 minus 35 equals to -10, plus c, -10 plus 5, -5, and that checks out. And for the rest of the different values in this column, I change the value of x to fit accordingly so that the math doesn't fail. Now moving on to question 2, display both curves on the graph using the same table of values. Second graph is changed with different BC inputs. Now, as you can see, the blue graph is y equals to x squared, and the red graph is y equals to x squared plus bx plus c. And if I were to change the values of b to, let's say, 3, the red graph changes. And if I change the values of c to, let's say, 8, you can see that the red graph changes again with y equals to x squared remaining the same. Now, moving on to question 3, display the numeric discriminant and numeric solutions to the equation x squared plus bx plus c equals to 0. Now, in this case, the discriminant formula, as we know, is b squared minus 4ac, but in this case, a equals to 1. So it can be simplified to b squared minus 4c. So that translates to f4 squared, as we said earlier, which is b minus 4 h4c, b squared minus 4c. And that will give you 13. As you can tell, so 5 times 5 is 25. 25 minus 4 times 3, which is 12. 25 minus 12, 13. And that gives you these two solutions, which the formula of these solutions are -b plus minus square root of the discriminant whole thing over 2. I split the plus minus into these two solution formulas, and that gives you these two solutions as you see here. Okay, now moving on to question 4. Given the function in the completed square form, y equals to x plus b over 2 whole thing square plus c b square over 4. Explain how y equals x squared plus bx plus c is shifted from the basic graph y equals to x squared. Now we know that y equals to x plus b over 2 whole thing square plus c minus b square over 4 is just the completed square form of y equals to x squared plus bx plus c. The term x plus b over 2 controls the horizontal shift for any given b input, and the term c minus b square over 4 controls the vertical shift for any given b and c input of the graph. Granted, these vertical shifts and horizontal shifts are using the graph y equals to x squared as the base. Now moving on to question 5. Verbally explain the changes in solution for the different discriminant values and display my conclusion statement. Now, we know that the discriminant is b squared minus 4ac, and as I said earlier, in this case, b squared minus 4c, b and c can be changed depending on whatever value it is. So the changes of solution are dependent on these discriminant values after finding out what b squared minus 4c equals to. And when discriminant is more than 0, there will be two solutions as we see here. When discriminant equals to 0, there will only be one solution, aka both x1 and x2 equals to the same value. And discriminant being less than 0, resulting in two complex solutions, which is what you may have saw earlier, #num. Complex solutions can't be displayed. And that's all from me. Thank you for watching. Have a good day.